Okay, so this is going to be our final session for now. So this session is meant to show you the raw data that you have obtained for your exercise that we got both here from both machine, STROPI machine and also ELIX machine. So the data from this machine, the moment you press the close lock on the screen yesterday that you saw that little tab, right? The moment you press it, the console will automatically turn all raw data into Excel form. Okay, this comes automatically, so it's easy for you. However, sometimes there is a known bugs to happen with this machine, especially if you have not updated the machine for quite some time. In that case, when you transfer the data, you're not going to find this Excel. You will find some kind of weird looking file. To open it, just open using Notepad. And then you can transfer this to here. Okay? Alright. So it's important once every 2 months. Update the blue stamp, which we can show after we're done with the data. Okay? Right. So these are the data from we got a few yesterday. We got the survey data, we got the light response, we got the CO2 response, and also the fluorescence data. Okay, so let me show you. So the coloring, we did the coloring because we need to. There are so many data that can come up from here. So you can see there's so much. So these are the name of the parameter. So much this is from a single log. So many data. So it's up to you, how do you want to utilize all these things. Okay. Yeah, so much data. Okay, I know that you might be overwhelmed by the naming of this parameter, right? So if you want to know, you need to go to LICOR. Kenapa ada burung-burung nyanyi pula ni? Diam. Mestilah. Apa yang tahu? Jauh datang sini. Nak kena minum lagi. Tengok ubat kata, oh betul lah. Memang perlukan healing. Yeah, I think I save it here. Yeah. Yeah. So if you go to LICOR, cari ni symbols. Okay, boleh cari kat Google lah. So dia bagi, it gives you the summary of all symbols in this machine. So if you scroll down, ini untuk Chamber Fatigue, we don't use this. Tengok kat bawah ni untuk dynamic that we did yesterday, right? Dynamic, gas exchange, and fluorescence. So it will tell you what all these things means. So untuk, for example, A, dia beritahu lah assimilation apa. And this is important for publication. You need to do the right figure, right? On the y-axis, what unit is it? Refer balik kat sini. Yeah. CA stands for what? CI stands for what? E stands for what? Yeah. There's a whole load of parameters description dekat dalam page ni. Okay. So we come back to this thing. Yeah. Right. So for the survey measurement, which we did yesterday, let's see apa yang dapat. So we got assimilation. Okay. Assimilation. Okay. I'll make this bigger. Yeah. Look at the unit. Micromole per square meter per second. Micromole of what? CO2. Because you are measuring how much CO2 is being fixed into the leaf by the action of Kelvin cycle, right? So kita ada dua pokok. Yesterday we got which one is it? Which one? Yang elite, which one is your lupa dah? The small one is STROPI. So big one is ni. Lupa kan? So STROPI, elite. Okay. Yeah. So this by tropical plant definition is actually rather low, but it is acceptable because this plant is house plant. Okay, anything that below 5, that is the regular reading for house plant or indoor plant. Okay, for vegetable that you grow under LED, such as the choice semua tu, usually the reading is between 5 to 10. Yeah. And for the tropical plant that you start to grow on the open yard, open sun, the same vegetable will have the reading between 10 to 20. Yeah. Rice and so on, usually is around 20 to 25. Okay. Yeah. So you can see that different plant species will have different assimilation capacity. Yeah. However, bear in mind, that's very important to pick the right leaf, because the same leaf, if you do progressive measurement, 1, 2, 3, up to 4, 5 days, you will see that the assimilation is going to decrease over time because the leaf is senescing. Yeah. Sebab tu, when I said earlier today, probably using frond number 17, maybe not optimum for you, because 17 is quite down already, right? Maybe some of the leaves have experienced senescence, aging. Yeah. So it's a good idea to go slightly higher. Go to the frond that has the first frond that started to go sideways. Yeah, it has started to capture the radiation, intercept the radiation. Yeah, and I think from the count that I saw tadi, mungkin around 12 from the top, and it's not really 17. Yeah. All right. Okay. What about stomatal conductance? So stomatal conductance is simply, so this on the different sheet. Stomatal conductance is in here. GSW. Remember, okay, G is the universal symbol for conductance. G, the S to indicate belongs to stomata. W is for water. It can be GSC. Bukan wayang tu. Stomatal conductance to CO2, carbon. It can be GSO, stomatal conductance to oxygen. But since this machine is measuring using infrared can capture water vapor, so we use GSW, right? So stomatal conductance, look at the unit, also mole per square meter per second. The rate of passage water molecules through stomata, right? So when you have higher stomata value, that indicates stomata are open. Yeah, that's the interpretation of it. So if you ask between these two plants, Elite's plant, even though the estimation is lower, the stomata open larger. Okay, so this, oh ada pokok, sorry. Kenapa tak cakap? Ya, aja. Malu, buka baju. Jangan. I said that once in the class, budak tu bangun buka baju. Ada, 2018 kot, budak dalam kelas tu. Ish, bahaya tu. Tak, budak tu memang some kind of exhibitionist sebab dia sukan, atlet. So dia memang panggil macam tu kan. Bahaya betul. Lepas tu yang perempuan-perempuan dia jerit lah. Okay. So even though you got all this in the value of numbers and then you turn it into graph, there is always biological explanation behind it. Okay, this is why people learn physiology. It brings together mathematics and the biology of it to explain phenomenon and also process. Yeah. So the phenomenon that you see here, stomatal opening. Yeah. Low assimilation means low carbon fixation. Okay. So when you bring these two together, assimilation divided by stomatal conductance, you get a new parameter which not originally present in the raw data. This is something that I created. Okay, it's called intrinsic water use efficiency, meaning that we divide by this. A divided by GSW. A is assimilation. GS2 is the conductance. Okay. So when you divide the top with the bottom, you do so because you need to understand. I show you how to turn it into one word to explain the biological reasoning. For one molecule of water, X molecule of carbon is fixed or assimilated. Okay, mathematician only use this. If you are a linguist, you need words to understand. Both means the same. Nampak tak? Sebab tu math dengan science go hand in hand. Dia tak boleh pecah. Right. So meaning that, so this will become a new parameter. We call it as IWUE. I stands for intrinsic, dalaman. Intrinsic. Yeah. Maybe if you are referring to the old paper, they use this, A divided by E. E is the transpiration. If you use this, it just becomes WUE, water use efficiency. The difference is, the moment you use stomatal conductance, you take into account the effect of boundary layer that I told you yesterday. So between these two, WE and IWE, this is more detailed. It tells you the actual rate of water passage due to the effect of stomatal morphology, or maybe the patterning of the stomata, right? So let's look at between the two plants here. Between the two plants, who do you think have more productive water usage? STROPI or elite? Gantilah dalam ni. You look at this value, right? 149. Meaning that for 1 unit of water loss, 149 unit of carbon is fixed into the leaf. Yeah. For STROPI, which is actually higher. For 1 unit of the similar water loss, 248 molecules of CO2 is fixed. So siapa lagi efficient? STROPI lah. Dua-dua lost 1 water, but one guy managed to do 149 jobs. The other guy managed to do 248 jobs. Nampak tak? Dia lagi efficient. Yeah. So this water must, there is no other way to get around it. The moment stomata open, water will be lost. Definitely. If stomata need to open, if stomata don't open, CO2 cannot get in. But the moment, so this is the dilemma for the leaf actually. That's why the leaf need to open and close all the time. They don't want to open all the time, because if they open a lot, all the water will be released to the atmosphere. If they don't open, CO2 cannot get in, right? A big dilemma. So the best of the plant are the ones that can have a superior stomatal control. I do not know for oil palm, but I can tell you the story for rice. For rice, based on my research, the best stomata for stomata control is big stomata that are less in number. Two things. Stomata are big, but the number are fewer. So these combination are the best for stomatal control. For rice, for alpha, I do not know. I don't think people kind of do it, that kind of study yet. But you need to do microscopy work and stuff. Yeah. So this tell you, this kind of crop, if it has these two distinct properties, maybe this is species 1, this is species 2, this gives you a good prediction. If you grow these two in a rather dry situation, right, maybe a drought, who do you think is going to perform well? STROPI. Yeah. You can use this machine to make this kind of decision now. Between these two species, this is going to survive well. Because even if they close the stomata a bit more, carbon assimilation can still be done. If this thing closed, very few assimilation will be done. Yeah. So for breeders, this information is very important because with the climate change and stuff, right? Yeah, yeah. So this can be created by you up to your interpretation. Okay, that's another way to do it. This is ICE, instantaneous carboxylation efficiency. How do you get it? ICE. How do you get ICE? A divided by CI. You know CI? CI here, okay. CI, if you go to this, here, in this column, CI. There are three kinds of C. C refers to carbon dioxide actually. There are three kinds of C. CA, CI, CC. CA, ambient, CO2, or atmospheric. Outside the leaf, has not entered the leaf. Ni, kat luar semua ni, semua CA. Kan? You blow to your friend's face, that's CA. CI is intercellular CO2. Intercellular means when you have plant cells, neighboring plant cells, the CO2 here. The CO2 amongst the plant cell. The CO2 has entered the leaf but has not entered the cell. Still dekat luar. Di celah-celah sel. CC, chloroplastic CO2. The CO2 has entered into the chloroplast. Remember the chloroplast that you used yesterday? CO2 in here, CO2 that has managed to get into the chloroplast, we call it chloroplastic CO2. So ada tiga. Yeah. So for ICE here, we divide A by CI. So meaning that for 1 unit of CO2 entered the leaf, X unit of carbon is assimilated. Okay, let's look at this. Got it. Easy kan? Elite for one CO2 that entered the leaf, only 0.01 unit of carbon that is assimilated. But for the STROPI, it's a lot higher. Yeah. So understand that it kind of the story of the leaf managed to capture light photon, light particles. Just because it has captured the light doesn't mean that it will manage to utilize the captured light. So in this case, just because CO2 managed to get into the leaf doesn't mean that the CO2 participate in the carboxylation of Kelvin cycle. Yeah. So this alone will tell you the efficiency of your Kelvin cycle. Meaning that this guy here, no need for further nitrogen fertilization. It's already good. If you want to decide between the two species, who to put more NPK, especially urea, go for this guy. This needs help. Because what? Because it is known nitrogen will improve carboxylation rate, is assimilation. Ya. Jadi boleh jimat input pertanian. Kan, the economic part of it. So you use this machine to make a sound decision. How much to give, how much to stop, maybe you need to delay. Yeah. Depending on the biological needs of the crop. Right. So what else can we see here? Yeah. Intercellular CO2, CICA. Mana CICA? No need this, patut buat CICA je. Yeah. Yeah. So these two you can actually got from here, but no need lah sebab I have explained here. Let's look at here. This thing in the fluorescence. Remember we did fluorescence yesterday? So this has been dark adapt. Remember FVFM stands for what? What is the name of this parameter? Maximum quantum yield. The highest possible ability of the leaf to capture light energy. Just capture. We are not talking about utilizing it. So between the two leaf, apparently the STROPI leaf 99%. I think this actually kind of a bit misleading because you didn't set the setting on the machine because your machine is new. It needs to be set according to the notes at the back. Yeah, I forgot this machine we have said it before. So refer to the notes, set the fluorescence setting first, then only you do the FVFM. So the FVFM is highly conserved at 0.8. Okay, right. Don't get too happy too soon because the 5PS2 will tell the actual story. After you have captured the light, what happens to the light? Do you do something with it or not? So 5PS2 tells you the efficient quantum yield, the light energy that participates in the photosystem electron transport. And you can see here, about 3% of the captured light is utilized for the ellipse plant, and not so much for this plant actually. Yeah, right. Okay, so that's for the survey measurement. Let's look at the light response curve. Okay, we can move with the light response curve first. Let me see. I'll take that. Mana LRC into the other group? This one. Yep. So we got two here. So this is STROPI. This is ellipse plant. Boleh tu. Yeah. Ooh. Which one has a decent plant? Let's see. Yep. Which one is correct? STROPI failure. You both group got have the same settings malam kan? Sampai betul? Sampai betul? Yes, I. Okay, now I have explained to you about the power of having these two parameter brought together, right, in the form of ratio. Imagine if you have a slight skill in mathematics. Can you imagine how far you can go with mathematics alone? And sebab tu ramai orang mathematics, they are very popular because they have very few things, but they kind of play around with it in infinity of combination, right? So let's look at the second thing in mathematics, which is the relationship of x and y axis. So we did the exercise yesterday, which is the response curve. Okay, ada dua kita buat semalam, light and CO2. Okay, so on the x-axis, we have the CO2 in the form of Ci. Okay, ppm. Oh, sorry. This is light curve first. I'll talk about light first. PPFD. PPFD stands for what? Apa benda PPFD? Kita buat quiz lagi ni. Okay. Photosynthetic photon flux density. What's the difference between PFD? What's the unit of PFD? Kalau nota ada ke malam? Dia micromole juga. Per meter per apa? Apa unit untuk PFD? Ada nota tak semalam? Tak ingat lah. Kenapa penyok benda ni? Apa benda? PFD. Apa? Okay, PFD stands for photon flux density. What is the unit for it? It is still micromole, but micromole of what? Micromole per meter square per second. Itu bukan ppfd ke? PFD. Berapa? Micromole per second. Macam tu. Oh, ini kalau masuk UPM ni dah habis kan? PPFD, is this unit correct? Okay, PFD is the unit correct? No. Dia tak. Apa?
Total flux, just flux.
PPF. Macam tu. Betul. Jangan tidur. You know, if you go to my class, tidur macam ni, habislah. Terus cakap habislah. My question always open Chrome, tapi tak pernah siapa jumpa jawapan. Some people even, I ask them to ask the dean for the answer. Tak dapat juga. You know, some university kan ada test kan, test, exam. You know, master exam bukan 2 jam kadang. I give them 2 days to find the answer. Yeah, all my test macam tu, 2-3 days. Tak dapat juga yang saya. Tak apalah, itu just to give you some exercise to connect biology, mathematics and stuff. Okay, let's look at this. So usually it's going to look this way. Okay, this is assimilation. Okay, assimilation. Assimilation. Right. For as the light increasing, you will have the increase of assimilation as well, up to a certain point before it becomes flattened. So if you can put an imaginary line here, this curve, we call it as a biphasic curve. Bi means two. Phase one, phase two. Okay? If you still remember from the notes given yesterday, potentially, this tells about what? Rasa. Apa? Dia ada dalam nota, I don't know, I have the nota with me. Should be Yep, should be overview of photosynthesis belakang sekali. Way at the back. What is this? Apa? Oops. Apa ni? So when you plot the curve, the response goes that way. There is a biological reasoning behind this as well. All right. So for the first part of it, it is called as light limited. Okay. Why is it called light limited? Because the slope is super steep, meaning that light is the only thing holding me back from the estimation to go higher. Right. However, coming to a certain point, maybe around 300 micromole of light, suddenly the curve becomes relaxed and eventually flatten off. At this point, light is not the problem now. The problem is the carboxylation. Carboxylation, usually we blame the enzyme rubisco. Rubisco is limited. But somehow if the plants manage to increase the rubisco, this thing will go even higher. Yeah. Hypothetical situation. So if we keep on increasing the light, eventually you might come down to here. Create an imaginary third line. So now it becomes triphasic curve. One, two, three. Light limited. Carboxylation limited. It goes down. Maybe the light here already 2,500 micromole. It goes down. What do you think the third phase is called? Too much light. Is it good or not for the plant? Why is it not good? Too much energy? What happened with too much energy? You eat too much energy as well. You should only eat like maybe 2 spoons of rice, but you eat 2 plates. Then so everybody, okay, fine, we'll create more fat for you. And go sideways. So is it a problem to have high energy? What happened? Exercise, fikir sikit. Potential scientific reasoning for it. Semalam dah belajar, light is energy. And then you shine upon the leaf. Apa dia? Jadi apa? Now light you give to the point of 2500 micromole, excess of energy. Potentially what happened to the leaf now? Kuning? Stress? Define it how? Stress, how stress in what term? Mata dia buta. There's only one word for it actually. Apa dia? I just want to dengar seseorang nak cakap apa. Apa? Tell me, apa potential jadi? One word, okay. The jawapan hanya one word sahaja. Stress. You want to use the stress? No. Too much light on the leaf now. Apa? Overload? Okay, overload. What do you want to call? Pressure center close. Actually betul, tapi itu dah happen kat sini dah. Okay. Alright. What about you? Burning. Getting that? Right, apa? Macam risau kan lecturer tu dah mula jalan. Macam mana ni? Stress. Okay, stress. Apa? Too much light on the leaf. What will happen to the leaf? Happy? Blind? Dia apa? Yelah, memanglah bright, dah cahaya banyak. What happened to the leaf now? When it received so bright of light. Dia apa? Layu. Okay, layu. Stunted. Dia kat dalam tu dah, nak pergi mana? Okay, stunted. Apa? Damage cell. Okay. Lagi? Kind of macam bening tadi dekat-dekat lah. Lagi? Overdose, OD. Okay. Okay. What about you? Die. Okay, die. Bolehlah join burn semua ni. Tiga ni, die. What about you? Dia kan will. Dah cakap tadi ada seorang cakap will. Tak boleh sama. Tak boleh sama. Tak boleh senes. Dah cakap senes ke? Dia akan will. Okay, dia nak will juga. Okay, what about you? Reasoning. Dia akan batuk. Okay, chloroplast hilang. Okay, what about you? Denature, apa? Protein denature, okay.
Tu plano jadi letih.
Pokok letih. Letih. Apa bang? Cepat, apa jadi? Pokok, apa daun jadi dry. Breaking out, tadi cakap damage ni sama lah. Cancer. Okay. Depressed stress tu sama lah. Okay. Macam-macam jawapan keluar. So can you imagine how entertaining I am when marking paper? Macam-macam cerita keluar. Kan? Unhappy, cancer, stress, diabetic pun kadang ada. Kan? Ya, saya OD lagi. Light is energy. You give extra energy, the first thing that will happen is actually a few getting there, dia akan merosakkan sesuatu. Okay, damaging. Okay, bila something, apa yang damage? What actually that got damaged in the process of excess energy? Membrane tu akan rosak sebab ada heat build up, and energy will cause molecule instability. You see, semua molecule, chemical molecule is bound by chemical bond, right? When there is an extra energy come, bond boleh pecah. Break the bond. When you break the bond, you will compromise, for example, membrane integrity. Right? And so many. Yeah, denatured protein tadi pun tu pun betul. Yeah. So the word that we're looking for the third phase of the triphasic curve is apa? Photo is the inhibition. Photo inhibition ataupun photo bleach. Tadi ada cakap ke daun tu hilang warna ke apa? Photo bleach lah tu. So photo inhibition or photo bleached. Sometimes sometimes the leaf can recover. But if it's too much or the leaf is still a baby leaf, it won't manage to recover, right? Okay, so too much of good thing is also not a good thing eventually. Okay, because in a leaf there is a limited amount of workers and factories to deal with all the ingredients coming towards your way. Given your canteen, guys, if you have a canteen, you have a aunties at the canteen, she can only handle with so much of cooking ingredient. And maybe in a day she can cook like what, 5 chicken. One day everybody just give 10,000 chicken to her. She cannot deal with that, kan? Mula dia masak, and then she got more stress, kan? Got stress, she changed. She changed, and then the whole canteen break down. So there is a moment of instability, right? So in biology, we don't want that to happen, because when that starts to happen, very likely the repair mechanism cannot take place soon enough to repair, right? Okay, right. Let's see what else is there. So this is the light response curve. Okay, what about the second one? So we're done with the light. What about the CO2 response curve? Kind of similar like this, but now we change the PPFD to CI in the form of ppm. Then we change, assimilation is still the same. The curve kind of look like this as well. As the amount of carbon increase, the first part, the name for this is called apa? Actually, I should ask my student, kan? Mereka pernah belajar ke benda ni? The first part of ACI, apa yang limited? Ya, kepak kau kau macam ayam ni. Carboxylation limitation, Rubisco limitation or limited. Carboxylation Rubisco carboxylation limited. RUBP regeneration limited. And the third phase is TPU limited. TPU stand for triose phosphate utilization. Triose phosphate sama sinonim untuk G3P tau. Glyceroldehyde 3-phosphate that you saw in your notes semalam. Okay, let's look at the CO2 response curve. In the first part of the curve, it looks exactly like this. What is limited here is the Rubisco, meaning that Rubisco activity, the carboxylation activity. Why? Because CO2 is very few. With the increase of CO2, there is a sharp increase in assimilation. Okay? One thing about Rubisco, it needs light to be activated. Rubisco that you learned yesterday. At low light concentration here, maybe the light here is 100 micromole. Very few Rubisco that gets activated. But as the amount of light is increasing, more and more Rubisco that gets activated. As more and more Rubisco are able to do the job, more number of carbon can be assimilated, which is translated in higher value of assimilation, right? Okay. However, when you come to a certain point, we can change this actually. We can from our exercise yesterday. Let's see, STROPI. Yeah, this is this plant, STROPI plant. It will start to relax. Okay, it's not perfect because kita tak prep betul kan. Tapi it should look something this way. It will start to relax. So this relax is known as RUBP regeneration limited. So the third phase of Kevin cycle, if you remember from the note yesterday, which is this. I'll show you sekejap. Ni. The first stage is the limitation of this phase. The second stage is the limitation of this phase, regeneration of RUBP. The regeneration of the 5 carbon sugar that will be fixed to CO2 in order to produce carbon precursor. Right? Why? Why is it? How can you increase RUBP regeneration? If you look at this, RUBP regeneration use ATP. So one way to do it is to increase phosphate by spraying phosphate. You know phosphorus? Yeah. Phosphate will be turned into ATP in the leaf. Yeah, that's one way to do it, right? But if you getting on to some point, it will go down as well, just like the light response curve. But this time, it's not due to the photo inhibition because photo is consistent here throughout this experiment for the CO2 response. This third phase of CO2 response, we call it triose phosphate utilization. This is not because CO2 is not enough or light is not enough. It's due to the traffic jam of sugar inside the cell. You see, as the CO2 increase, the chloroplast will start making lots of sugar, right? So much sugar until it becomes too crowded. It cannot make more sugar unless the old sugar has left the chloroplast into the cytosol, into the veins, go to other places, the sink organ. Yeah, this situation we call it triose phosphate utilization because the carbon precursor, it has various destiny. It can become glucose, it can become sucrose, it can become starch, anything, right? But it has to become something and leave the chloroplast. So chloroplast will not make any further assimilation even though you give extra CO2 until the sugar that has been produced here, the sugar precursor here, goes somewhere. You need to leave the chloroplast, okay? So one thing which is useful in terms of this is to have variety, perhaps variety that has higher vein number. You see, veins in leaf is meant for plumbing work, piping system. The more pipes that you have, the quicker the sugar can leave and go somewhere. Yeah. So maybe you are testing two variety. You can see that variety that has less vein number will quickly experiencing TPU limitation event compared to the leaf with higher vein number. Right? Yeah. So that's one way. There are many ways to reverse triose phosphate utilization issue. Okay, but one way is having a better piping system, or simply help the cells to convert sugar precursor into something else, right? Glucose in plants does not move, okay, from one place to another. Sugar that move in plants, not in the form of glucose like our blood. No. Glucose is super reactive. And plants, for some reason, it's a bit smarter than human. So they change the glucose into something less reactive, such as sucrose. Okay? So, people got diabetic because glucose high. Glucose high is one thing. That glucose is doing damage to the protein in our body because it's circulating in our blood, touching all the arteries, all the veins, touching all the protein. Touching is fine. Touching and pinching. Right. Along the way, people are screaming. Because glucose is very reactive. They like to touch everybody and make people scream. Sucrose is a non-reactive sugar. So plants have this adaptation. Even though they produce lots of sugar, never in history you hear plants got diabetic and needs to be amputated. Faham tak? Kenapa? Nak ke mana? Oil palm, nak pergi potong dah berdahan. Macam mana? Tak ada. Tak ada. The reason is, simple je the reason dia. Because the circulating sugar dalam plant circulation system is not glucose, it is sucrose. They use non-reactive sugar. Right? Okay? So that's a medical story that I want just to share with you. Right? Okay. You always wonder, kenapa plants got diabetic? They're producing all the sugar, right? How come they don't get gangrene? But my ama just lost 3 legs. Amputation 3 times, 3 legs. Or already chopped 20 years ago, and then chop again. Okay. All right. So coming back to reality. Okay. So I just want to show you this thing. Look at this thing. If you want to use this machine, just bear in mind because semalam you turn on DAT, dynamic assimilation technique tu. Nampak there is a drop in here. Okay. The reason is, budak ni tak sedar. Kan? Kena aku juga yang sedar. When you create DAT, when you check DAT, you will have a new column in here. This column. Dynamic column. Ni, semua ni. So, kesannya adalah you will have 2 assimilation reading. This reading, steady state reading, and dynamic assimilation reading. Okay? You need to use one as your assimilation. Okay? If you want to use the dynamic one, my advice is untuk response curve, don't use dynamic lah. Use dynamic untuk measure survey sahaja. Yeah, because we do not have SOP lagi sebab DAT LICOR baru cipta. I do not have the SOP how to deal with it. Okay, maybe very soon. Budak-budak ni racing ke nak buat further study. Kan? So to be on the safe side, when creating response curve like this, use the regular assimilation which is A steady state. This one, ASTY. Okay. However, if you just want one reading, quick reading, like pagi tadi kan ambil kan reading, boleh gunakan assimilation dynamic. That is fine. Right. Okay. I think untuk quick interpretation, I think itu sahaja. Any question? Yep. Do you have any question? Session petang ni memang untuk interpretation dan for you to ask further things. Okay, we just leave some room for discuss or you want to talk about your study. It doesn't have to be about LICOR, maybe some kind of, isu terpendam dalam hati. No, who knows? Kan, humans got so much issues. Kan? I don't know, maybe you saw something at your kampung and you cannot explain it, That uncle used the hacking saw, do something to the tree, and then now, after 20 years, it's flowering again. We thought it already dead. Why, Or somebody asked me ada hari tu tanya. Actually, there is a reason why that happened. Ada soalan ke tak ada? Tak ada.
Saya mau nanya satu soalan yang lain. Apa plant yang carbon assimilation tinggi itu?
Carbon assimilation tinggi?
Ya. Ini plant with high.
Oh, yang ni per given area per second dia very high. Dia macam ni. Kalau compete between different photosynthetic modes, C4 will always win. C4 such as apa tu? Corn, maize. Semua tu akan win. Tapi within C3, one of the highest is actually rice. Rice super high. I used to get sometimes 30 the value. You got tadi pagi berapa? 10, 11, right? You're reading on the palm kan? Rice simply got 30. Yeah. Yeah. So soalan tu mungkin boleh refinekan sikit. Tanya macam the highest among C3 plants. Sebab photosynthetic mode ada 3. Sebenarnya ada banyak, tapi dalam buku teks ada 3 saja. C3, C4 and CAM. C3, most of the plants on the planet, and including this plant, your oil palm, padi, pokok mangga, kan? Tu buah limau kangkuat raya Cina tu. Right, semua C3. C4 tak banyak dia evolve daripada grass, C3 grass. Corn, tebu, ya, C4. CAM adalah succulent plant, pokok yang berjus di dalam, aloe vera, cactus, orchid. Ya, tu yang ada kat tingkap tu, kalanchoe tu, pokok stawa tu. Bukan Star Wars, stawa. Tu yang ada on the leaf ada banyak anak keluar atas leaf dia tu. Tu C4 juga tu. Bukan C4, CAM. Crassulacean acid metabolism. Yep. Among CAM, that kalanchoe is regarded as high. Kalanchoe tu. Among CAM. Right? Nenas is CAM. CAM. Nenas. Tadi yang cakap kan tanam pit dekat nenas juga kan? Nenas dekat pit juga kan? Yes. So, if you are growing oil palm dengan nenas, sebenarnya you are dealing with 2 different photosynthetic modes, which is C3 and CAM. Good luck lah. CAM tu. It's ada susah sikit nak interpret dia punya data. Susah sikit. Sebab dia they don't open stomata during the day. They open stomata at night. So the carbon fixation that you saw here, this stage 1 carbon fixation here, completely happened at night. For CAM. And they happen in specialized cells. During the day, they transfer all these fixed carbon during the night to a new cell. These new cells will do the regular Kelvin cycle during the day. Fixation waktu pagi sebab stomata completely close during the day. So, as a student, masa degree long time 20 years ago, the way I remember this is I kind of feel sympathy for this plant, CAM plant, because they have to work 24/7. Kan, malam kena fix the carbon, pagi kena buat carboxylation and stuff, right? So I changed that CAM into cubalah anda memahami. I have to do photosynthesis all the time. You know, budak-budak kan paling nak ingat macam-macam. I have created so many weird formula in my head. Tapi lah, it works. Memang ingat. Alright, okay. Ada lagi soalan? Ya. Apa? Hah? Nak buat written test? Okay. No, written test aku nak kena fikir dulu macam apa boleh. Kenapa last minute nak cakap? Tak ada. Itu Pak Haji tu yang pergi ria. Tak ada. Bye. Apa? Tak berhati? Sue me. Your boss, it was said that, wants you to be given exam final. Lepas tu kan dia orang buat soalan. I don't know lah, who's your boss? Kena buat? Open horizon, ancestors all call in. Okay. You want to make a small ritual at the corner of the room? Do it. Coil. Yeah, light ignite all the incense. Kejap ya. I don't think it's the proper thing. Satu, people need to be told. Number two, I need to prep first. Bukan semalam kita buat exam ke? Kita ada quiz malam kan? Malam kita ada quiz malam actually. Kan? Saya ada markah lagi. Saya ada markah. Oops, sorry. Yeah. Okay, yeah. Ya, ya. Aha. Oh, tak dengar? Dah, tadi kan dengar. Ceritalah kat kawan. Stomata. Kejap. Nak juga aku yang explain. Nak test? People like to ask me untuk buat soalan. You know, lembaga periksa Malaysia just ask me untuk buat soalan form 6 untuk this year. They just called me yesterday. Semalam dia call? Bukan. The day I arrived here. Petang dia call. So actually kan, it's very precious to keep me because I know soalan form 6. Tak buat lagi. Tengah nak fikir nak buat soalan apa. Alright, stomata. I give you sikit je lesson stomata. Maybe this is of interest sebab ramai scientists that I know dealing with carbon management, water cycle, they all learn about stomata. All of them. Okay. Alright, stomata. This is plural tau. Dia punya singular dia stoma. It's a from Greek word. Greek Yunani, bukan Greek Perak tu. Maksudnya mouth. Mulut. Okay. So, stomata in general morphology means form. Morphology, which is form, is divided into two. Okay, which is the kidney or bean shape ataupun dumbbell shape. Dumbbell. Tahu dumbbell? Kau lelaki tahulah, perempuan ni. Lepas tu dia tahan perut dia masuk dalam. So the kidney bean, it looks something like kidney lah. Tak pandai lah nak lukis macam tu kan. Kidney lah. Kidney. Yang dumbbell dia bentuk macam ni. Bentuk dumbbell lah kan. Bentuk macam mana lagi? Oh, I during student time I call it bentuk tulang anjing. Yeah, and usually dumbbell shape ni dia ada lagi extra cell kat belakang. So dia ada for one unit macam ni, for one unit ada dua je kan. Ini namanya guard cell. Guard cells. So 2 times guard cell, 1 2 guard cell sama dengan 1 stoma. One unit of stoma. So stomata is actually referring to this whole structure. Untuk yang dumbbell shape ni, dia ada 4 sel. 1 sel, 2 sel, 3 sel, 4 sel. So 2 and 3 ini adalah guard cell yang biasa macam ni. Yang 1 and 4 we call it subsidiary cell. Subsidiary cell, bukan subsidiary anak syarikat tu. Subsidiary cell. So 2 guard cell plus 2 times subsidiary cell. So ada 4. Ya. Your oil palm is this. Rice is this. Rice ni. So lain. Okay. So this talk about stomata morphology. About stomata apa ni? Positioning. Maksudnya the location of the stomata ada 3. We call it hyperstomatus, hypostomatus, lepas tu amphistomatus. So when you have a piece of leaf, kan, ni bagi 3D sikit, ada nampak kat bawah kan, tu macam lipat dia. Pandai pula aku lukis. Kalau macam huduh-huduh kan. So hyperstomatus maksudnya the plant only have stomata on the upper side sahaja. Kat bawah tak ada. Completely ke atas. Hypostomatus, stomata only present dekat bawah sahaja, tapi kat atas tak ada. Amphistomatus, atas bawah dua-dua ada. Hyperstomatus contohnya pokok aquatic. Water lily, hehua pula. Lotus, aquatic plant lah. Hyperstomatus dekat bawah sebab it's in the water kan. Ada stomata. Hypostomatus is actually banyak pokok including ni. Most plant is actually hypostomatus, terrestrial plant, land plant. Hypostomatus, stomata dekat bawah, atas tak ada sangat. Very few, if not completely zero. Amphistomatus dua-dua ada. Contohnya macam grass, padi amphistomatus. Dua-dua ada. Okay. The ratio in stomata in this machine, dia nak tahu stomata tu more or less dekat atas bawah tu sama banyak ataupun one side is more. If you put 1, maksudnya the ratio top and down of your leaf that you clamp in the machine is similar. 1, sebab katalah the top number is 1000, the down number is 1000. 1 lah. Okay. Tapi if one side is more, maybe you want to put 0.3. Kan? So one side is actually, this has to depend on the literature or your own study using a microscope. However, if you are unsure the stomatal positioning or ratio for your leaf that you clamp into the machine, simply put 0.5. That's a safe number. So it will assume somewhat stomata tu divide equally atas bawah. Yeah, 0.5 is the safe kalau tak tahu. Tapi kalau if you know, lebih bagus. The assimilation reading yang ni kan, assimilation macam ni will be more accurate. Itu je stomata tu, stomata ratio tu. Berapa cerita kau buka ni kat sini kan? Tak apalah.
So, kalau juga bermain ke atas dan bawah sama lah.
No, bukan atas bawah tu sama. Maksudnya one of the machine will assume one will have more than the other ataupun the other way round. Sebab it clamp both kan, atas dengan bawah, tapi sebab dia tak tahu mana satu. Yep. Mungkin di atas tu completely zero, bawah tu ada, ataupun both atas dan bawah dua-dua ada separuh-separuh. So that's why dia letak 0.5 tu. So kalau nak selamat, put je 0.5. Tapi kalau you happen to read a literature about oil palm leaf morphology and stomatal patterning, dan ada yang menunjukkan bahawa stomata rupanya ada dua belah, atas dan bawah, underside and downside, and in equal number. Kalau macam tu, dia is amphistomatus, letak value 1. If. Yeah. Alright? Okay. Tak apa, I can go on jawab soalan sampai masa habis supaya korang tak payah exam. Kan? So kau kenalah create soalan. Nanti kalau bos kau tanya, aku dah balik, nak kena pukul, iseng kau. It's not me. Tea break? Aish, baru makan lah. Tea break apa awak ni? Wah, I need to I need ubat lagi. I know it can be a bit struggling sebab kita semua umur dah ke depan. Lepas tu nak belajar balik benda-benda macam ni kan. This should be learn masa kau masih kurang dosa. Alright. Sekarang kan macam-macam dosa kau buat dengan jiran, kau tak kira dah lah. Banyak mana. Kan. Lepas tu makan lagi lah kan. We found vegetarian bakwa 2 days ago. Pernah jumpa kat Semenanjung benda tu. Kenapa bakwa? Kau masih tak makan bakwa? Kenapa bakwa? Dia tak tahu bakwa tu apa? Benda tu. Yes. Aku tak ada makan babi tu. We found dekat kedai. Apa nama tu? Pali. Dia jual bakwa vegetarian made from fungus. Rasa dia pelik. Open horizon. Open your head, open your mind, call ancestors. What about other group yang are not dealing with this equipment? Do you have any concerns regarding your science?
So,
Yeah.
Kami orang tower.
Tower?
Yang dia any correct flats. So, kami orang mau contribution by pump apa dia sequestration tu sana in relation to the tower flux medium.
What data coming from your tower? Data apa? CO2 flux. Tell me macam mana exactly benda tu measure? Dia just measure at certain level ke? Dia macam dome shape? Dome. Okay, itu masuk kategori CA. Ambient CO2. CO2 that has not entered the leaf. However, CO2 available for the plants to use. Okay. CO2, if you measure at different height from the ground all the way up to 5 meters, dia akan lain tau. Dia ada CO2 profiling dia. Dia akan jadi lain. So it is known that if you keep CO2 high dalam area canopy, this will contribute to high carbon sequestration. Yeah. So that's why some people, they purposely shoot some kind of wind towards the canopy, sucking all the CO2 from other place untuk tembak ke arah canopy, because they want the canopy to capture and sequester the carbon. Only during 9 pagi sampai 5 petang. Not throughout the day. I know some people do that. Yeah. Sebab if you shoot the plants during the night, siapa nak buat photosynthesis? Right. You can shoot all you want lah. So people use this timely carbon concentrating mechanism, shooting to the canopy at the right time of the day, so that the carbon sequestration is maximized. However, if you are dealing with CAM like nenas, you do the carbon movement to the crops not during the day. You do it at night. Nampak tak sama? Lain. So that's why one reason kenapa kena faham photosynthesis, if you are talking about carbon sequestration, it matters when the carbon reach the canopy, depending on the type of the plants. Yep. So like your say your flux tu kan, the flux tu kalau dia just measure around tu, itu adalah ambient CO2.
So, we all know that the flux radiated and already measure photosynthesis dalam papa.
Boleh. Contohnya, your tower tu at what height? The sensor of CO2?
Sekarang 20 meter.
20 meter? Sebab tadi I saw your plan, that's about 5 meter saja kan? Ke kurang? Yeah. Let's put it this way. Some areas have shown that kalau that particular region high in CO2, the vegetation become lusher. The biomass accumulation is higher because CO2 is more available to the plant. Okay, so dia macam ni. You have more CO2, this CO2 will follow concentration gradient into the leaf. Okay, if the CO2, like let's say that sekarang dekat luar the reading is about 400 ppm, but maybe in your area it is slightly higher, maybe around 430. That extra 30 ppm actually can make a difference in your plant. Okay, so over the time, plants that have received higher CO2 concentration environment, automatically there will be changes both in the stomata morphology and also the physiological identity of the leaf. The leaf will be having more rubisco for sure, and this can be translated into the reading of assimilation. Macam ni lah. This thing. Yeah. So let's say that you have the data from the tower, and then you see that this region high. Sepatutnya assimilation should be high as well. So you prove by it. Matching tak data tu? Okay, compared to the region yang maybe CO2 dia lebih rendah. Yeah. If you have a high CO2 in your region, tapi carboxylation is just regular, nothing improved about it, then maybe you might want to consider stomata maybe not opening. Maybe we don't give enough potassium actually, because one element that can control stomata opening and closing is potassium. Potassium. So people yang they are trying to do carbon sequestration, they understand stomata, right? They like stomata to open at the right time of the day. They give enough potassium. Yeah. So bila pokok tu ada enough potassium, memang stomata buka, banyaklah karbon masuk. Yep. Right. Okay. Does that? Yeah.
Okay, so sekarang saya tanya soalan yang lain lah. So pokok tu stomata dia open dia sunlight kan? Kalau sunlight stomata buka kan? Kalau in the morning.
In the morning, yes.
Yeah. Kalau kita setkan light untuk 24 hours to get what is the effect of the carbon assimilation?
24 hours light.
Yeah. LED light yang mereka pakai.
Pengsan pokok tu nanti. Tak boleh 24 hours. Pokok dia kena ada waktu dia gelap, bukan untuk tidur. Plants do not sleep, okay? The reason plants need to experience darkness so that cell expansion can take place. Bila tak ada cahaya, baru starch boleh breakdown. Bila starch breakdown, baru the sugar tu boleh digunakan untuk cell to expand, memanjang. Yeah. That's why you see growth sebenarnya banyak berlaku at night. Yeah. So actually my student dulu FYP long time ago lah, 6-7 years ago, she actually grow pokok tu. Lain aku suruh lain dia buat, biasalah kan bela-bela. They grow the plants in 24 hours light, and then I went to UK sekejap. Bila balik kan pokok habis jadi kuning. Betul tak tahu kenapa. Rupanya dia tak tutup lampu sebab dia nak the plant to grow faster. Yeah. You know pokok macam kat luar ni kan, they are exposing to sunlight, right? It's not like they can go to Watson and buy Nivea to apply the sunscreen. They are accumulating tons of free radicals such as ROS. Okay, reactive oxygen species. So these free radicals has been accumulated throughout the day and it needs to be neutralized somehow. So sebab itu pokok kena berehat sekejap waktu malam so that the natural antioxidant dalam pokok boleh neutralize all the free radicals so that it is ready for the next day. Yeah. So the sense of pokok tidur waktu malam tu kind of tak sama dengan manusia. It's different. Okay. Right? Okay. Does that answer the question? Somehow. Yeah. Hmm. Ada Bill Gates tengah funny benda tu tapi tak jadi pun. Bukan jahatnya aku kan cakap projek orang tak jadi. In 2004-2005, Bill Gates have started to ask a bunch of the best of scientists on the planet to come together, and then he fund a project called C4 rice, changing C3 rice into C4. Sebab C4 is known to be super productive. Tengok macam ni ya. Padi, jagung, dua-dua keluarga grass, keluarga rumput. If you grow both at the same time, you can harvest corn in 70 days. Completely, boleh makan semua. Rice, you need to wait 120 hari. Extra 50 hari. Kenapa? Sebab C3, bila panas, dia jadi kurang efficient. So the idea is, if rice could have the C3 mechanism, it could be harvested 70 days just like corn as well. Jadi banyaklah biomass. However, based on the study, because I almost got accepted into the group, but my supervisor kind of mungkin he sense something. Actually, baguslah tak masuk kan. Kalau tidak, malu. Actually, I was the only one yang dia purposely tak bagi masuk. Yeah. The whole floor in my university masa tu, dia orang memang work on the C4 rice. We'll get some semua. So I actually met Melinda. Melinda tu the wife, dah divorce sekarang lah. Nama foundation dia Bill and Melinda Gates Foundation. Yeah. Yeah. So apa jadi dengan projek tu sekarang? They have managed to do two things, tapi masalahnya benda tu revert jadi bentuk asal. Yeah. Satu, lepas tu they can't really get the architecture of the leaf correct. C4 plants, dia ada special leaf architecture tau. Dia panggil crans anatomy, which C3 tak ada benda tu. So they need to correct the structure dulu. Yeah. They need to correct two things. The structure of the leaf, internal, must be correct, and then the biochemical pathway. Maksudnya all the enzymes that are present in corn plant need to be present in the rice as well. Which is, are you having a God complex? Susah nak buat kan? Yeah, but it's been 20 years now, almost 20 years. Major milestone have been achieved. Diorang confident benda tu masih boleh pergi. Tapi tak ada produk pun yang sampai dalam market lagi ataupun untuk real field testing. It's not easy. It's not easy. Remember, okay, scientist yang Bill Gates hire ni is some of the best dalam dunia. Right? Yeah. Not to worry. Actually, we have found a better way than C4 rice. Tengok buatlah sekarang. Maksudnya even C4 rice to work, still cannot beat our simple method. So macam, siapa lagi bijak kan? Bukan bijak, orang malas. You know, orang malas will find an easier way to finish thing. That would be me. Yay. Alright. Okay. Ada ke genetics group dalam ni? Maybe that will be a very colorful addition to the family if you have them. You know, you can study about breeding, molecular marker, semua benda tu. Yeah, I know those things, tapi tak adalah buat banyak pun, sikit-sikit saja. Yeah. Yeah. All good. Yeah. So mata lagi. Okay, okay.
Dalam phase 1 Fluorescence tu ada 14 community. So dia dapat beza dia. Terus tu sama environment. So dalam dia ada pattern dalam distribution dia. Ada satu side pun dia memang sangat banyak in terms of physiology.
So you have a species of orchid, tapi this species happen more in one place than the other. What kind of orchid genus? The diversity of the orchid. Let me get this correct. So one region has more orchid diversity compared to other region that you are comparing to. Density. Okay, alright. Actually kan pernah masuk soalan bukan di dalam exam. I didn't teach orchid but somebody else teach. I like to tengok orang lecturer lain punya soalan exam. Saja kan nak sibuk tengok orang tanya apa, lepas tu aku tengoklah skema jawapan. Salah. Like to judge people along the way. That's my joy in life in my office. Judging other lecturers. That actually when I need to recall, that was 7 years ago. I saw somebody buat benda tu. Susah lambat nak indexing when you are aging. Dia nak kena cari laci mana satu. Okay. Some orchids, when it happens to be flourishing in certain region, there is a good chance dia punya symbiotic mycorrhiza is also present dekat tempat tu. Number one. So the good study is to take the medium and then bring to the lab, tengok what kind of mycorrhiza is present in there. Microbes count dia panggil teknik tu. Microbes or maybe fungus count, spore count pun boleh juga. So sebab one thing about orchid seeds, I'm talking about orchid seeds tak macam oil palm. Orchid seeds do not have endosperm. Endosperm is the food reserve for the seed. Because of this lacking of a structure, in the wild, in nature, orchids rely 100% on the association with mycelium of specific fungus in order to germinate. So this fungus kind of acting like the extension root to absorb the nutrient, then allow the seeds to germinate into an orchid plant, right? So kalau kata satu tempat tu ada banyak tu, there is a good potential that symbiosis relationship is happening at a very flourishing rate. So maybe a good study untuk tahu adalah kenapa fungus tu suka hidup dekat situ. Fungus we know, nombor satu dia tak perlukan cahaya, kan? Mungkin the humidity is just correct, the temperature is just correct. We call this microclimate. Yeah, the microclimate combination is just at the right sweet spot. I call it bliss point. Kan? You know, you like to buy all the product kat supermarket yang manis-manis tu kan? This manufacturer have found the perfect bliss spot. What you are buying is actually sugar. Cuba dia buang sikit sugar tu 3%. Semua orang tak nak. Right? So in the nature pun macam tu juga. Yeah. So there are ada sebablah kenapa mycorrhiza tu ada boleh jadi banyak. That's a lot of reasoning. It can be biological reasoning and also environmental reasoning. Okay. Orchids in the wild dia tak boleh tumbuh on its own kalau kawan dia tak ada. You can say that tak apalah, marilah kita gunakan fungus from our tempeh. We got so many tempeh, near our house. Use the tempeh, the mycelium from tempeh, give to the orchid seeds, hoping these orchid seeds to grow. Tak jadi. Sebab orchids ni, nombor satu, dia tak makan tempeh. Macam, you are not my gang. Go away please. Yeah. Sebab tu orchid industry kan 100% tissue culture. That's why. Sebab tu. Sebab almost impossible to find the BFF fungus for the orchid species. Almost impossible. Mungkin BFF dia dah long lost apa, tak ada dah. Yep. So boleh buat macam tu lah. Okay. Kan? Tengok ada bagus tak? Jadi sibuk-sibuk kan, kepo-kepo tengok orang buat apa. Kalau aku tengok, aku tak jawab soalan dia. Actually, masa tu, that lecturer tak boleh mengajar 3 minggu. So, in my faculty, they like to turn me into bidang terjun tau. So, mana-mana subjek yang tak boleh ajar, dia tiba-tiba, macam aku macam padi, dia pun ajar orchid. Kau rasa macam mana? So, I need to do all the speed reading. Nasib baiklah melekat dalam kepala kan. Aku kena ajar. So, dapat. Okay? Good. Ada je, tengok orchid, lagi tengok apa? What time now? Ya. Kuat sikit.
Tadi kita ada sebut kita ada pernah buat kerjasama dengan PIP.
Ya, bukan kerjasama, saya untuk ajar dia orang.
So mereka pernah buat measure photosynthesis atas STROPI kan?
Dia guna, dia macam ni. Some of them that I know, dia memang ada team yang ada lesen memanjat. Memanjat kena ada lesen tau. Ya. So some of them ada lesen memanjat. One, then kalau ada pokok yang macam susah, they are studying the epiphytic plants, orang kampung kat situ yang pergi bawa, pergi atas buat turun bawah. Ya. Macam mana nak bawa kereta ke hutan? Right, bukan ada highway yang tu.
So kalau dipotong kan dari atas ke bawah ke bawah kan macam tadi kita potong mesti masuk air terus.
Pokok kat hutan dia potong the whole branch tu. The whole branch tu bila dia potong, some plants, bukan plants tau, some trees they have this resin quickly form. Dia jadi plug benda tu, so memang that branch is stable sampai 1 hour 2 hours still okay. Yeah. So selalu kat hutan macam tu, they cannot be too extreme sebab ialah dalam hutan kan. Right. Yeah. Some of them is actually, I think mungkin dah buat lah kot, dia gunakan drones. Yeah. Bukan dia bawa ni, bawa terbang drone bukan bawa ni, menjerit bos dia. Ini 3x90. Imagine 3x90 terbang ke atas. Orang jerit. Guna drone tu itulah, tak sure orang tu, sebab I wanted to ask juga, tapi rasanya dia orang kind of potong benda tu, potong the branch tu untuk bawa ke bawah, and then immediately letak dalam air or some kind of solution untuk preserve dia punya osmotic pressure. Yeah. So dia buat macam tu.
So dia spesies tak buat satu atau semua spesies?
Dia selektif lah, dia tak buat semua. Dia buat some of them studying apa ni, some kind of, you know, some forest species dia ada wintering, daun dia bertukar warna. Some of them do that species, so dia fokus species tu je lah. Some of them pun ada yang buat ni epiphytic plant, macam tu apa tu, the bird nest fern tu. Tapi bukan the bird, there are many species lah dekat hutan. Buat macam tu. Yeah. Macam bird nest tu kan, if you cut the branch, the bird nest still in the branch, so it's still alive. Tak ada apa pun. Yeah. Just sebab the science is very tricky and dangerous kan, people just need to be very creative to get the plants. Yeah. Who knows? In 10 years time, you got Platycopter. We want di atas. Alright, all good. Macam mana ni? Kita tak sampai pempat lagi. Kita dah kena bagi exam ke? Dia orang dah tanya soalan. Semua orang dah nak balik. I'm going back. Bukan, I'm going back hari ni. I'm going back tomorrow. Banyak. Done with you. Next week, I rasa I need to go pergi tuai padi dah. Panasnya. Tahu tak padi panas? Panas tau. Dekat Perak. Panas. Macam SPF 500 pun tak boleh handle. Ya.
Salah satu lagi extra question yang kalau kita ni lah.
Ask me for earth to heaven. Call all ancestors.
Pushkan flowering to kok tu. Macam durian ke, bukan ke macam mana buatkan dia flowering 3 times a year. Sebab kalau durian tu lah, dia biasanya flowering after a dry season. Dry season dia stress to develop flowering.
Actually kan you just answered your question.
So stress,
Bukan macam ni. Even if you give the treatment to trigger flowering, if the flower don't set, sebab climate tak betul, tak guna juga. We can use all the chemicals dekat lab untuk trigger flowering. Tapi the moment the flower come out, this is not the environment I want to live in. Pok jatuh. Unless you spray the floral stimulant and then you keep your durian in glass house. Then that's fine. Sebab dia jadi masalah macam tu lah. You low floral and fruit setting bila dia trigger flowering ni. Sebab climate tak betul. I'm not worried about banyak produk untuk trigger flowering. The question is, the moment the flower is up, can the climate be suitable to the fruit development? So benda-benda macam ni bagus untuk pokok. Some people actually grow mango dalam shelter. Shelter kan boleh control. That's fine lah. That's fine. Anggur kan ada orang grow anggur dalam shelter kan. That's fine. Buat floral ni and then they change the control environment to facilitate floral development and fruit development.
What if kalau kita control yang soil moisture dia bagi dia stress dia?
Soil alone is only 10% of the story. What about the rest of it? Until from earth to heaven banyak lagi. That's why I said I'm not worried about banyak cara untuk trigger flowering because dekat UPM 2 years ago, my own department, they have had this pokok anggur for 10 years. Lepas tu tak berbunga. Then they asked me to taking care of the courtyard. I did something to the pokok anggur tu. 2 weeks later memang berbunga. But I said to the head of department, don't be too happy. You didn't put the right awning. Kejap lagi tornado nak datang. All the flowers yang banyak tu habis jatuh. Climate tak betul pula. So akhirnya dia orang pun macam give up dah, biarlah pokok ni tak berbuah pun. At least it looks pretty kan. Right. Unless kalau kita grow di dalam control environment. Kalau tidak, rugilah. The hormone, the regulator tu tak murah selalunya kan nak spray. Kan? Even kalau spray pun mungkin yang jadi, you hope you get 20 fruit, dapat 1. Kan? Itu pun pokok tu macam kesiat. Bagilah. Kan? Macam dah berusaha sangat dah ni. Ya.
Growing durian kemsang di shelter.
Oh, kat mana? Ada?
Di Semenanjung, yang berdekat yang orang si durian itu dia sama dengan company, dia letak lagi durian pun dalam ada
mungkin orang tu pun dah sedar sebenarnya climate, if you want to get durian, seasonless durian, that's the way to go.
Sebab yang the main problem major makan durian kan dia already develop fruit, tapi
Fruit setting masalah tu. Low percentage of fruit setting. Yep. Itu memang masalah. So actually whatever I said just now, at least you know I'm not scamming you. Somebody already doing it. She just verify kan benda tu.
People what one of the factors causing the yang why factor yang menjadikan atas flowering yang
It can be anything. It can be some kind of crazy bat flying through and then plop langgar jatuh. Kan? The bat is chasing some kind of vampire bat, another vampire bat. Kejar, plop langgar jatuh. It can be anything. Nature is crazy. So kalau macam tu, kalau nak trigger tu, I suggest you kalau betul nak buat kat luar lah. Kalau betul nak buat kat luar, dia ada satu, tak tahu lah sekarang ni buku ke apa, dia ada weather almanac. So that you can study dia punya weather pattern tu sikit. So that the moment you spray ataupun bagi treatment apa, soil treatment ke whatever treatment lah, you know to do it at the right month. So the likelihood untuk berjaya tu lebih tinggi. Kalau dah tahu hujan adalah masalah, carilah bulan yang precipitation volume dia agak rendah. I think if you go to Wikipedia kan, if you type any city name, let's say I put Shanghai, dia bagi tahu tau precipitation value. Let's see, mari tengok. Let's fly to Shanghai. Kan, tersedak Singapore. Kan, I have a collaborator there. Kat sini kan, mari kita klik Shanghai. Nak Shanghai lagi Suzhou, jalan. Kat bawah-bawah ni selalunya dia ada cerita weather precipitation rate ni. Ni ke? Ni climate yang tak best nak negeri ni. Bagi. Mana climate? Tak ada. Kejap. Ya, Shanghai climate. Dia patut ada dekat dalam ni. Tak ada ya? Kenapa tak ada ya? Kau selalu ada ke? Sekejap. Temperature. Oh, dia macam ni. I want the big data tu. Sekejap. Mana ya? Give me one city in the world. New York. New York je. Ada. Ini ke? Kan? Ni. Benda ni. Ni. This thing. So dia bagi tahu macam ni kan New York, if you are worried about precipitation, you can look at this average ni. Maksudnya bulan yang paling kering potentially adalah January, February. Kan? Tapi you need to avoid bulan-bulan yang nombor 4, which is April jangan, June jangan, kan? So maksudnya you can start your spraying around November sampai February. Ada 4 bulan boleh buat. Based on the city lah. If you want to grow your durian in New York. Kan? No. New York pergi je kan. Bagus tak benda ni. I use this a lot actually. Dulu masa student nak buat decision nak pergi, because dulu I like to travel untuk cari botanic garden. Negara Four Seasons ni, every season kan keluar pokok baru kan, that you have not seen before. So I plan according to benda-benda macam ni. Nak tengok macam some orang kata dulu kan sebelum pergi duduk dekat negara 4 musim, I thought you only see flowers during musim bunga, which is spring tau, bulan 3 sampai bulan 5. Rupanya kan after some time dan guna this kind of guide, ada some species yang sebenarnya berbunga waktu apple harvest. Contohnya bunga dahlia. Dahlia season adalah waktu apple harvest, which is end of October, Halloween time. Dia tak berbunga macam yang lain-lainnya waktu spring, bulan 3 sampai bulan 5. Walaupun dia dalam garden yang sama, negara yang sama. So that is the behavior of dahlia. Lepas tu I know lah, rupanya dahlia sebab dia gunakan tuber and everything. Okay, I got it. So that's interesting to know. Tak tahu. boleh lah Pak nak plan, tengok sakura kan. Ni nak datang ni sakura, nak sibuk lah nak ajak aku pergi. Bukan tengok sakura. Sakura is the flower. The sakura viewing is called, what's the word? Hanami. Bunga tulip waktu spring lah, bulan 3 bulan 4. Bulan 3 bulan 4. The one I said berguna dahlia tu, that's special case sebenarnya. Semua bunga sebenarnya tak bunga dah. Waktu Halloween hujung Oktober, early November, dahlia is the only exception. Masa tu I learned it. Oh okay. So that's why I know. Oh, some species actually you need to know the season ni. Sebab dahlia they need the correct microclimate. They need low photo period sebenarnya untuk trigger flowering. Sebab dia adalah short day plant. Remember you learn yesterday? Short day plant. Dahlia tu short day plant. So that's why dia perlukan the Halloween time, which is longer darkness untuk flowering. Macam student, bijak lah aku. Kan bayangkan kalau aku jadi classmate korang, mesti jadi terancam kan. Alamak, dia ni ada lagi. My student always tiru me. Dia suka tiru apa saja aku tulis. Kan? Suruh buat malas. Oi, apa nak aku nak merepek ni? Amir tak nak cakap apa-apa. Tengok penat orang datang. Bagilah ucapan sepatah dua kaki kata. Ya. Storage? What about it? Oh, the storage ni. Macam cakap semalam, dah tak gunakan. Yang water column ni release. Yang ini pun eloknya release juga. When it comes to the new day, kan, walaupun you don't change the chemical, always going to shake it. Sebab apa tau? Sebab kita nak, we don't want it to clump in here. Kalau clump in here, nanti gas tak boleh gerak. Shake it. Yeah. Jaga elok lah. Walaupun benda ni tahan asap, don't bang it against the wall. Right. Yeah. Kalau buat eksperimen lama kan, macam 3 days straight, tak payah buang ni pun tak apa. You know, kabel ni semua dia ada nyawa dia tau. Berapa ribu kali dia boleh keluar masuk. Sampai one time, the pin in here akan bengkok. Ya. Tak adalah macam even the Samsung yang fold tu pun 250,000 kali kan. Buka tutup. Ini pun tak lama juga. So kalau dah memang ada measurement 3 days non-stop, when you done at night ke, tak payah buka lah semua ni. Just put it to sleep, release this, esok terus continue all the cable. Right. Yeah. Lagi kurang movement alat ni, kan, you are manhandling it, lagi panjang nyawa dia. Kan? Nanti kalau nyawa dia pendek, nanti aku kena datang lagi. Ya. Kalau nak travel boleh travel, kalau nak bawa flight kan. Gunakan bag ni, jangan guna bag lain. Please, jangan guna bag lain. Bag ni memang dah padded dan bag ni boleh kunci lah. Dia boleh kunci bag ni. Kan dari tepi ni. Kunci. Gunalah rantai lembu apa. Kunci. Cable tie. Ya. Oh, satu lagi, CO2. CO2 ni, CO2 cartridge yang nampak semalam tu, dia serang meletup lah sebenarnya kalau dia berlaga-laga antara satu sama lain. If you want to bring to travel, walaupun bukan flight lah, dalam kereta ke, wrap it individually dalam tisu ke atau paper. Padded kan dia. Jangan bagi dia berdentum-dentum satu sama lain sangat sebab pernah meletup. Kalau dia meletup, nombor satu macam ada lagi tak jantung ni. Dia sejuk. Satu tempat dia sejuk. Ya. Dia macam explosive prone sikit. Benda tu. Kalau sikit-sikit tak apa. Jangan violent lah. Kau pergi bawa naik kuda ke kan. Lepas tu benda tu pula tak padded kan. Every gallop of the horse riding, every time dia explode. Pom. Kan je sejuk kan, nanti the whole house get frozen. Okay.
Update ni, update software,
Huh?
update
Oh, update software. Ya.
laptop tu.
Kau nak tunjuk ke? Asyik aku je. Okay, last thing. We show you how to update the blue stem. Tunjuk. Yalah.
Mana kabel? Kita dalam
Tunjuklah.
telefon.
Sudah ni kan, kau kena paksa dia tau. Kalau dia tak paksa, siapa-siapa pergi kau tak nak apa. I kind of like cerita Cinderella, mak tinggi dia tu.
Sebab kita update.
Show that. We will use your machine. Mungkin connect ni apa? Number one, you need to go to LICOR punya website. Tunjuk Afiq? Kat LICOR website. Cabut. Oh, pakai tu. Sampai ke? This update penting juga tau untuk fix the bugs and masalah. So I recommend 2 bulan sekali just check dekat website LICOR ada tak update yang baru. Set dah timer. Planet. Perforing lah. Oh, tea break. This is my tea break. Tak dapat apa? Tak dapat apa? Tu tak cari apa-apa? Tu kena ni, duplicate. Ya.
Sunlight itu dia ada kalau satu macam nanas sudah satu ada sunlight, satu tak ada sunlight. Yang dekat sunlight itu dia lebih manis, dia ada efek kalau ada sweetness of sunlight.
Sweetness, number 1 untuk nanas memang genetic control. Environmental tu number 2. Dia memang genetic control sebab naturally dalam plantation kan guna ethopon to trigger the flowering. Sebab if you leave naturally, nanas lama nak berbuah. People apply ethopon. So variety ni memang ada ability sendiri untuk be responsive to the ethopon and then do the flowering. Then how much it can sink the sugar to the fruit. So itu genetic. Sebab sangat macam ni, negara kita memang lebih kurang sama panjang malam tu. So sunlight tu kurang sebenarnya impact dia. Unless you grow it in a super shaded area, so mungkin ada effect lah. Yeah. Some people they grow plants under shade kan. Cukup. Dia macam ni. Even I can tell you one thing. Even though the light is reduced, the fruit is still sweet, tapi it will take longer for the pineapple to produce fruit. Yeah. It knows what kind of sugar content it needs to achieve. So kalau selagi dia tak capai tu, it will just prolong the fruit development time sampai the sweetness is achieved. But it's a tight genetic control. Yeah. Walaupun ada shading kan pokok tu boleh dia design untuk grow slow. So that they still dapat gula manis tu. Oh, okay, no problem. Alamak, ada quiz. Macam mana ni? Alamak, wait, is this the time you are judging me? They are judging me. Alamak, they are judging me. Yalah. Do I care? Do I care? Yalah, aku baca kat bukan kan? Yalah. You know, lecturer kan sangat takut disam orang. Not me lah. I will compete up for my students to criticize me. Because, oh, by the way, you are less 10 marks anyway. Nak exam? Nak tengok soalan exam? Ada soalan undergrad? Sekejap. Ada lah ni, sekejap ya. Exam last week. Final EPM kejap. Dia campak exam. Ni undergrad dia. Alah senang ni, kata gila. Dia ada soalan ABC, so ni soalan ABC. Kejap. Macam mana? Senang soalannya kan? So ni soalan ABC, lepas tu ada soalan AC. Oh, apa dia? Oh! Kejap, korang nak tunjuk sana ke apa? Aku merepek. Okay, dah nak tunjuk ke? Boleh. Okay, tunjuk dulu ni. Tunjuk dulu ni.
Tadi sambung ni punya tembok RJ45 kan? So, saya ke LICOR.
Tak ikut tu. Afiq, kalau cari kan? Dia tak sampai. Cari kat dalam.
Tak apa. Cari je LICOR. So, pergi dekat environmental. Pergi dekat support ni, ada button support ni. So, cari 600 lah.
Ada 6400.
6400 ada lagi.
Ada lagi.
Oops. So, pergi dekat soft. Dia ada kat sini operate instruction apa semua lah. So, pergi dekat software. Cari firmware kan. So, sekarang ni dia dekat sini 2.1.09 yang paling baru. Yang sekarang ni 2.1.08. So, download ni. Selalunya yang paling baru duduk atas sekali lah. Kalau pakai Mac, yang ni lah. Ni kita pakai Windows kan. Okay, download dia. Sini dia suruh letak lah. Apa lah nama? Saya guna nama. Ni tak ada apa. Email apa? Kalau tak isi rasanya tak boleh kot. Nama ya.
Dia dah email kat baru. Tak jumpa lah. Masuk longkang lah. Dia set apa notification untuk activate the card. Your card lah. Kita tak kena pokok tu kan kuasa terus kita letak kat dalam pokok kelapa kita tidur. So dia kata dia hantar 20 We have mailed out your new credit card 27. Kan, kita nak belakang lagi kan? Mama tak cakap apa tu. Mak aku tak ada kat rumah. Tapi I call the bell lah tu. Tak dia hantar notification so activate. Maksudnya kat tu is somewhere. Tak ada kata nama. Dia just kata dia we have mail. Dia just cakap we have mail. Your kan? Semua. Sebab tu hari tu ada surat masuk dalam pokok. Pos pelik-pelik lah orang ni pos yang kat sedang. Hak dia cerita kat pokok.
Tapi kalau nak update ni, kena bateri tu full ataupun sambung dengan dia takut tiba-tiba dia crash ke.
Dia tu tak tempat yang pelik-pelik.
Jadi so far dia tapi
Tak update dekat sini. Dia akan guna kabel.
Pokok lah, kita masuk dalam longkang.
Semua kena install dia punya updater ni dulu. Sama juga yang satu lagi apa viewer tu.
Itu dia letak masuk dalam tu. Mungkin dia selit dalam water filter.
Bukan ini untuk update. Untuk viewer tu kena download.
Sebab sebab tu tak ada orang. Kita tak ada orang. Kena cari.
Yang tu download benda ni lah. Kalau nak pakai lah. Sudah ada? Kalau sudah ada boleh connect ya. Oh dah ada. Oh dah download dah. So masuk je lah kat situ. Masuk kat situ double slash.
Wah, tekun orang exam.
double slash.
Tu masuk sekejap. Double slash tak payah. Masukkan 68C. Ikut dia punya. Ikut dia.
I like to kata student.
Ikut terus.
Sebab dia bagi dia doubtful. Tak ada.
Tak payah.
Tanya ada 7 jabatan.
Cuba connect. Betul lah dia punya nombor.
Apa dia takut tu?
Sekejap.
Betul kelas. Kita ni. Macam tak ingat tak?
Tak boleh. Sekejap. Dia ada dekat main dua dia. Guna IP pun boleh.
Dia. Jangan buka tu. Buka biar dulu semua.
Oh sorry, dia kena tambah dot local belakang.
Okay.
Masuk balik.
Tengok semua orang kamu tak sabar nak balik kan? Dah lah hari Jumaat. Betul kau buat lambat-lambat. Diorang pergi pasal mana? Kat mana?
Dot
semi you.
local. Yang satu lagi. Okay.
Tak tahu dia bawa. Ikut driver.
Oh tak boleh.
Metro City? Kat mana? Bertam? Bertam jauh gila kat mana? Kau pergi ke Penang kau?
IP tak ada ni.
Oh, steamboat.
Sekejap, nombor dah betul.
Makan tadi pun tak kenyang, tak lapar lagi. Saja je, tak pernah pergi pasar malam kat Sarawak. Like datang Fiesta tak pernah pergi. Saja tengok. I like to judge people along the way. Ada putih.
20 kilo.
So ada apa? tak, maksudnya Metro City tu apa macam dia
Betul kan?
bandar lah.
Kucing.
Oh.
Semarahan.
Yang ada laksa.
1, 2, 4
Belum. My tourist guide is very poor.
Kabel dia okey.
Betul
lah.
You should be judging my tourist guide on that part.
Buat. Memang tak
Boleh lah nak
jadi dia.
pergi. Tak, semalam macam jam lah, hujan lah. Kenapa suka jam kat sini kan?
Semarahan. Dia berjaya.
Oh. Suruh buat flyover banyak-banyak.
Tu boleh control kat
Metro City, dia sudah nak. Dia pun tak tahu, padahal aku di sekolah sini kot. Di sekolah konvent dulu.
Cici mai.
Boleh?
boleh. Mana ni?
Ya, di mana ni?
Tadi tu tak boleh sebab salah alamat atas tu ke?
Tak sambung.
Oh.
Ni saya install
So.
okey. Dia.
Apa makanan should I test dekat pasar malam? Yang kuih-kuih yang pelik-pelik ke? Yang makan sekali will never forget. Macam, oh, this thing.
Sekali makan tak tahu.
Oh, boleh juga.
Ambuyat.
Bagilah suggestion. At least boleh cari nanti.
Makan dia boleh yang sebelum. Gue ke pasal malam.
Kanlah takoyaki Jepun.
Takoyaki. Ni update dia 2.1.9 yang saya install tadi. So tekan dia punya konsol lah sebab kita nak update dia punya ni kan. So kita pergi dekat
Sekolah petang ke? Kuatan dia orang lari.
update. Dia ada tulis ni update lah. So update lah.
Awal sikit lah.
Yang ni yang lama sikit lah.
We should be avoiding waktu budak telefon.
Tu yang dia tak nak ada macam
Pergi ke arah
bateri.
mana-mana. Tak jam pun. 50. Dia dekat mana? Kecil lah. Tak tepi je dulu. Coming soon. Kita lagi. Kalau kau boleh ada lagi.
Tak sambung tadi.
Nanti pergilah conference MSTP bulan 9.
Apa tu 54 minit.
Kat mana? Kat mana? I know lah kat Kuching. Waterfront. I'll be doing another magic trick. This time kan solving real student.
Teori lah jadi mangsa. Ada.
Banyak magic show nak buat kat universiti. So console dia je lah. Sikit je. Okay lagi. So you can see, okay, once you run this updater, dia bagi tahu tau if the other parts. Remember we learned the three important parts, kan? Dia punya head, dia punya parameter tu dengan dia punya console tu. So far updater. Okay. Mana masuk dalam tu? Mereka kan perempuan kan? Jadi dah macam jerit-jerit kan? Okay. Mic ni untuk ni. Nanti benda ni masuk dalam apa playlist YouTube tu. Boleh lah korang tengok korang punya blur. Oh macam ni. That's how I look. Ada siapa grad UPM? Ke semua orang grad UPM? UPM. Apa? 5 orang? 6 orang? Orang baik. Apa? Buat apa? Degree ke master? Oh tak nak buat. Terus tak nak buat. Tengah buat. Oh, Bintu lah ada UPM kan? Kerjasama memang tak akan lah sebab nama dia kerjasama. I don't like people kan? Tapi kadang-kadang ada lecturer daripada Bintu tu datang ke campus, main campus. Sebab dia ada small project. Degree. Ramai ke tengah buat master? 2? Tu dia angkat tangan 2 lah. 3. Oh ramai. Lepas tu dengar all my scary story kan. Habislah. Kan baik kan sebenarnya. Dapat. Lama dah buat degree. I'm so old. My degree like 20 years ago. Tua dah. Dah lah. Korang pernah ada display soil chamber yang bulat tu? Tak ada? Ada klien pernah beli? Dia pernah kayau, ada isu? So benda tu kind of direct je kan. Dia tak ada tak meletak je situ. Okay. Okay, dah update ke? Alright. Okay. Yang belakang-belakang ni kan kau tengok pun kau buat apa kan? Yang ni kau kena. Okay, dah tengoklah macam mana nak update. Tak apalah, tak tahu nanti tanya your friend yang tahu. Makcik-makcik kat belakang tu. Bertenang. Nyok nyek. Dah. Nak tunjuk apa? Oh, dia nak tengok soalan exam. Kejap. So, ini ada grade je. So dia ada soalan macam ni, soalan apa? ABC. Dia ada ABC. Soalan ni last week. Alah senang aja. Macam kata dia ada dua dia. Apa benda tu? Ni pasal soalan seed dormancy. Generally tengok soalan photosynthesis kan? Macam mana soalan photosynthesis? Sekejap ya. Ni. Cuba jawab soalan ni. Nombor 8. Nombor 9. Ada 3 ni, kejap ya. Besarkan sikit kejap. 8, 9, 10. Jawab. 8, 9, 10 jawab. Nombor 8 tu apa jawapannya? Ada hadiah dia. Ni, ada 2 pokok. Nombor 1, the light reaction centers during photosynthesis are commonly referred to Sama jawab. Semua huruf sebut. This table. Kita we go by the table now. This table. 1, 2, 3. 3 guys here. Jawapan untuk soalan nombor 8. The light reaction centers during photosynthesis are commonly referred to apa? A. Betul ke? Photosystem 1 and 2. Agree? Betul tak? Betul. Okay. Nombor 9. Tak apa, benda recorded. Nanti bos tanyakan kata, ada tak exam ni? Okay. This table, okay? Nombor 9. During light reactions, molecule of oxygen is derived from dapat dari mana? I told this yesterday. Datang dari mana? Apa? This table. E. Apa? Lembu kambing apa? Dadu. Reduction of NADP. Betul ke? Nota ada. Dalam tu dah cerita. Oh. Cepat apa? 10, 9. Group lain ialah C, E, F lah. B. Boy. Splitting of water. Betul? Apa nama proses tu? Apa nama proses tu? Ada fosforus ke? Photolysis. Okay. Alright, okay. Alright, number 10. Meja belakang. The dark reaction during photosynthesis occurs in ni tak tahu sajalah. Nombor 10. Apa? Meja belakang. 3 orang. A, B, C, D. Yang lain relax lu. Macam mana? Jawab huruf jim. Tak ada jim kat sini. Nombor 10. Cincau. C. Stroma. The dark reaction during photosynthesis occurs in cincau. In C. In stroma. Betul? Betul tak? Betul lah. Kevin cycle kat stroma. Dekat posh chloroplast. Alright. Ada lagi tak? Soalan cam. Baru cerita cam tadi kan? Meja ni yang bising-bising ni makcik 4 orang ni. Jawab nombor 11 ni. Which of the following statement is or are true about CAM plant? Baru cerita tadi. Yang mana? A. CO2 fixation occurs at day. B, sabar. B, first stable product of photosynthesis is similar to C3 plants. C, the Kelvin cycle is operative during the day in bulbous cell. Or D, A, B, C, E, A, C. C. So jawapan C adalah the Kelvin cycle is operative during the day in bulbous cell. Agree? Siapa agree dengan jawapan C? Boleh angkat tangan? Dia orang pun tak nak angkat tangan, dia pun tak agree dengan diri sendiri. Macam mana? Mencadangkan? Mana mencadangkan? Kau nak jawab. Orang lain ada 3 orang, kau ada 4. Cepatlah, apa? C ke? Final answer? Segan tau persatuan kepo-kepo. Kalau kau salah. PPK. PKP. PKKP. Persatuan kepo-kepo. Cepat. Apa jawapan dia agak-agak? Betul tak CO2 fixation occurs at day? Tadi cakap apa? Camp plan tu? Malam. So A dah tak betul. What about B? First table of product of photosynthesis is similar to C3 plant. Betul ke salah? Salah lah. Nama pun CAAM. Sila lain kan? What about C? Operator dia? Sila jawapannya. Alah, baru cuit sikit dah dia. Hidup kena confident. Saya mempertahankan jawapan saya. Tak nak dengar ni semua kiri kanan bising-bising ni. Meja belakang soalan saya tu kini. Kejap, ada kejap. Apa soalan photosynthesis kejap ya. Ada ni. Kejap. Sabar. Kejap. Sekejap ya. Gibberellin, apical dominance, plant growth hormone. Sekejap. Tapi yang lepas ni semua soalan essay dah. Kejap. Ni ada satu nombor 29. The reduction step during the Kelvin cycle, what will happen? ChatGPT, A will generate ATP, B will consume NADPH, C will translocate triose phosphate into the stroma. Dengar banyak kan triose phosphate tadi. O, D, A, C, E, B, C. Diberi masa sebentar untuk berfikir. Meja belakang sekali. Meja depan dengan persatuan PPK boleh bantu. Mana? Ya ke B? Remember tahu Kelvin cycle ada phases, right? Apa? Okay. Kejap lah nak dengar. Apa jawapan? Table at the back. Apa huruf? Apa dia? B for bola. Will consume NADPH. Okay, tengok betul. Mari kita tengok. Double check. Nombor 1, will generate ATP. Betul tak? Tak betul sebab this is not photosystem. No. C, betul tak? Will translocate triophosphate into the stroma. Betul tak? Tadi I said what? Kalau chloroplast tu dah jam sangat, apa dia kena buat? Dah traffic jam sangat gula dalam tu. Dia kena keluarkan. Dia kena keluar. Tapi ini keluar ke? Ini kan dalam lagi. Jadi jawapannya B. B3 question ni. Bagus. Sepalang. Okay, C tu soalan trik sebenarnya. Dia kata translocate triose phosphate yang nampak tadi kan, TPU, triose phosphate utilization tu into the stroma. Tak betul lah, stroma masih tempat yang sama. Dia tak bergerak mana-mana. Lain kalau dia kata translocate into the cytoplasm. Itu betul. Dah lokasi di luar chloroplast. Alright. Alright, okay. Oh, 30. Sama jawab 30. Which of the following is not involved in the photophosphorylation process? Foto maksudnya proses tu gunakan cahaya. Phosphorylation maksudnya dia tambah fosfat ke dalam molekul tu. Mana? Enzyme. Siapa kata jawapan, okay ni ramai-ramai jawab, I just want to see. Siapa kata jawapan dia A? I want to see. Mari tengok, mari kira berapa orang yang jawab A. Mana Rabu? What's the tak nampak. Okay, berapa orang jawab A? Anybody nak jawab A? Which of the following is not involved in the photophosphorylation process? Tak ada? 0. C, D. Ada siapa nak jawab B? Enzyme? Okay, 1, 2, 3, 4, 5. 5. Okay, ada siapa jawab C? Kena jawab tau? Tak jawab kan? Yang oh ni jawab 1. Ni kira juga. 1, 2. 2. 2 Siapa jawab D? 1, 2, 3, 4, 5. Tu nak jawab ke tak? Tu kenapa tangan macam tu? Tu jawab ke tak nak? Semua? So satu lagi sekali siapa jawab ni? 1, 2, 3, 4, 5. 5. Siapa nak jawab E? None of the above. Siapa jawab E? Okay, siapa jawapannya? Soalan dia sekarang dia nak tanya, yang mana tidak terlibat di dalam proses photophosphorylation? Photophosphorylation tu dah tadi bagi tahu kan, perlukan cahaya. Kan? Maksudnya cahaya perlu. Enzim?
Tak perlu.
Tak perlu. C tu perlu tak? Perlu? Betul ke perlu? ADP? Okey, jawapannya adalah, sekejap aku kena fikir. Skema tertinggal kat UPM. Actually, they gave me the schema, terhilangkan. Tak tahu pergi mana, terbang. Banyak soalan I did, soalan trik sebenarnya. Lepas tu kan diri sendiri yang terpedaya. Not involved in the photophosphorylation. Okay, light involved definitely. Enzim tak involved. RUBP involved. ADP. So jawapannya sebenarnya adalah B. Bola. Sebab apa tahu? Light memang perlu untuk energize the process. RUBP memang perlu sebab RUBP tu yang menyebabkan the whole thing digunakan ATP tu. ATP di revert balik jadi ADP. ADP adalah precursor untuk phosphorylation. So jawapannya adalah B. Yeay. Soalan essay? Habis dah. Soalan senang aja. Light is one of the important element for photosynthesis in plants. State the function of accessory pigments. Apa dia? State the function of accessory pigments such as chlorophyll, B, carotenoid, xanthophyll, dia bagi tahu dah semalam. Apa? Siapa ketua kelas? Cepat saya ketua kelas. Okay, kau ingat aku nak tanya dia. Ketua kelas, point to me, who do you want to answer this? Siapa? Dia. Cik apa nama? Dah tak ada, tak boleh reverse lah. Apa nama? Kevin. Jawab soalan A. State the functions of accessory pigments. Semalam dah tengok dah. In fact semalam soalan quiz pun yang korang joget-joget depan whiteboard tu. Ada video by the way. Kenapa? Untuk apa? Apa fungsi accessory pigments? Accessory pigments kita tahu kan, macam-macam warna dia ada dalam daun tu. Merah, biru, kuning, kelabu, biwai laut. Apa fungsi dia? Boleh bagi dalam point form. Sebenarnya fungsi dia banyak. Untuk? I think he's literally tanya ChatGPT sekarang. Saya tak ada nota. Kawan tak nak bagi nota kat dia ke? Kevin, ada siapa yang rasa boleh bantu?
Macam itu pun.
Niko dia tak boleh patah balik kat orang asal. Cucuk orang lain. Cucuk. Siapa nak cucuk? Siapa? Alia? Siapa Alia? Cucuk. Cucuk. Jawab. Apa fungsi accessory pigment? Accessory pigment tu apa? Bagi contoh. Benda-benda ni lah. Semua pigment selain chlorophyll A adalah accessory pigment. Untuk apa? Kalau absorb light energy, chlorophyll A pun absorb light energy pula. Light energy apa? Tak, ayat tu tergantung. Kena sudahkan sikit lagi. Light energy yang apa? Satu perkataan lagi nak tambah kat situ. I say that only you can choose. Elok-elok dia nak panggil. Apa? Light energy yang apa? Apa accessory pigments buat kepada something of light energy? I was telling you something about sunscreen, apa benda semua tu semalam. Yelah, apa bendanya? Nak pas dosa kepada orang berikutnya? Dosa boleh dipaskan sekarang. Siapa nak terima dosa berikutnya? Dia tak boleh lawan, jangan risau, tak boleh buat apa. Cucuk je. Siapa nak cucuk? Siapa? Tak sampai hati. Kenapa? Tak apa. Tak sampai hati, sampaikan tangan. Show. Siapa? Mana? Ni, depan ni. Abang apa nama? Apa? Eddie. Okay, Eddie. Apa? Fungsi accessory pigment.
Chlorophyll B absorb blue and yellow light.
Yelah, apa bendanya? Secara collectively apa fungsi dia? Tadi dia dah jawab, tapi tergantung jawapan tu. Light energy yang apa? Macam ni, cuba fikir. Try untuk fikir secara kritikal. Tahu sunscreen? Sunblock? Apa guna sunscreen dan sunblock? Macam mana cara dia protect? Reflection dan yalah, dia absorb. Pasal dia buat apa? Dia absorb, dia pass. Okay, pass tu buat jadi apa? Spread, hilang. Ya, dia pass hilang. So, filter excess light energy. Filter. Supaya apa? Supaya the right energy of 680 nanometer is achieved to activate special chlorophyll A molecule. Baru elektron tu keluar daripada chlorophyll dan run the electron transport chain. Itu je jawapan dia. Senang. Okay. B. The light and dark radiation that make up photosynthesis are shown in figure below. Siapa pun kerja tu? This is not my question lah. Explain briefly the energy production on the use of light. Alah, kesiannya. Did I teach this malam? Dan tak je. Dark radiation that make up photosynthesis are shown in below. Briefly explain energy production in the usage of light radiation. Okay, I think semalam tak ajar kau benda ni. This is the part that I didn't cerita. Untuk macam mana dapat ATP. Sebab semalam kan overview je. Right. Tengok dia dah lari, dia takut. Sepatutnya dia passing dosa sekarang. Yup. Right. Okay. Dah. Itu saja habis dah soalan posisi. Stephen photo period. Dah. Yeay. Okay. Alright. Okay. I think itu saja kot dah 65 lah kan. So, hopefully ada membantu, ada belajar sesuatu. Ada belajar. dah serik nak panggil. Bayangkan if you go into my class, habislah. I don't only teach photosynthesis sebab banyak subjek ada kan. In fact, subjek pertama I taught kan sebenarnya weed science. Ajar racun herbicide. Tak pasal-pasal kan kena ajar benda tu. Yeah. But please don't ask me untuk teach ni organic chemistry. Wah, tolong jangan. Alright. Okay. Amir ada apa nak cakap untuk tutup? Bagi pihak Pak Haji and Co. Alright. Okay. So macam mana ni? Diorang dah kira dah buat exam lah tu. Kan? Dia dah buat exam lah tu. Tak apa, ada bukti. Ada bukti. Kalau bos tanya ada bukti. Siapa datang? Siapa?
Dia tak datang.
Okay.
Sebenarnya dia kata
Entah, tak ada kot. Okay. Tak ada apa. Okay, tak ada apa. I think itu saja. So thank you for coming. I hope you enjoyed the show. Kan, my magic show maybe out of the world. Apa nak group foto lagi? Dekat depan mana? Oh, ni dekat parking kereta. Okay, tolong kliki.